Hi guys, so we'll be starting with the rules of indices. So first of all, any variable to the power 1 is always equals to the variable itself, but any variable to the power 0 is always equals to 1, so it doesn't matter what number it is. For example, if it's 100 to the power 0, it's always equals to 1, or like 1000 to the power 0, 999 to the power 0. Anything to the power 0 is always 1. So over here, for example, we always call x the base and m the power. So when you're multiplying two numbers together, and if the bases are always the same, then the base on the other side always remains the same. For example, 3 and 3, the base on the other side always remains the same. The difference is that the powers add up. So m plus n, so it becomes n plus n. Over here, it becomes 4 plus 5, 9. So even if the powers are the same, for example, 3 to the power 3 times 3 to the power 3. The base will remain the same. That is 3 as well. That is 3 as well on the other side. That is 3 as well on the other side. And the powers will add up. So 3 plus 3 is 6. That's why we'll write 6 here. And then over here, when it's dividing, when the bases are the same, but the two numbers actually being divided, so the base on the other side always remains the same, but the numbers end up getting subtracted. So for example, it's the same thing as 3 to the power 7 and 3 cubed. What actually happens is 3 to the power 7 goes up, and 3 to the power 7 is already up. 3 to the power 3 goes up, and when it goes up, the power gets converted into a negative number, and then you just add. So 3 and 7 minus 3, 4. Over here, since there's one base, but it's in a bracket, so whenever anything's in a bracket and there's a power outside, the powers always get multiplied together. So the powers get multiplied, and then you can evaluate this whole expression. For example, if it's 20 to the power 5, and then you're multiplying it with 2. So it becomes 20 to the power 10. This is only the case when there are brackets, and if the whole variable is inside, but they're two separate variables, so m first gets multiplied with x, then m gets multiplied by y. So over here also you can see 2 first gets multiplied with 3, and then 3 separately gets multiplied by the, not multiplied, but exponent. So 3 gets the power of 3. Over here, the same rule applies. So x to the power m and then y to the power m. And over here, this is basically a repetition of the rule as stated over here. That anything to the power, for example, if it's a negative power and you want to convert it into the positive, you can just reciprocal it and this becomes positive. If you want to bring m upstairs in the numerator, then it's going to be minus.